Okay, today we will talking about the theory of elasticity. Again, just a little bit review, and then we will move to derive the basic element for plane stress problem. For plane stress problem, that is, we will focus on just only constant strain triangle elements. Okay, as we studied last week, we know that uh, the state of stress at a point, the state of stress at a point for any body that's subject to the stress field, we can consider the small elements that is subject to the stress field, and we can define the state of stress of that point by stress tensor that is composed of 6 components, that is sigma x, sigma xy, sigma xc, sigma yy, sigma yc, and sigma cc. Actually, you see from the tensor, you know that it is a 3 by 3, it's like 3 by 3 matrix, but because of symmetry, so the 3 by 3 matrix, that is actually it should be 9 elements, is reduced to 6 components. Okay, so the stress tensor in 3-dimensional is composed of 6 components. Okay, and in order to write the state of stress in correct notation, we have to use just only these 3 types of notation. Okay, so we will move to uh, just for example, this case that is simplified to be just only 2-dimensional problem that you have learned in mechanics of material. I select this example from the text of Ferdinand Beer. Okay, so according to this state of stress, the state of stress at a point, for example, this point, okay, the red point over here. Okay, so if we consider this, so can you write the state of stress or the stress tensor according to this picture? Okay, so according to this picture, we know that we define Cartesian coordinate, the positive sign convention like this, and according to the positive sign convention that we already defined from the state of stress above, we can write the state tensor that is for this picture like this. We have sigma x that is 50 megapascal, that is positive, right? Okay, the sigma x, and sigma xy that is 40. Okay, for this case that is 40, and also for the sigma y is compression, so it is minus, this is negative sign, minus 10. If we write in just only 2-dimensional, you familiar with, it's just only this. It is a stress tensor of the state of stress for 2-dimensional problem, 2D plane problem. Okay, but if we would like to expand it to be 3-dimensional, it will like the same, but you have to add the C component also. That is, for this case, it's just only 0, and it's the same. Okay, this is we call the stress tensor of the state of stress of the point that we would like to know. Okay, and then according to this, if we would like to find the principal stress that is the stress, the normal stress on the plane that the shear stress is equal to 0, that is give us the maximum and minimum value of normal stress. We can determine by using this formula, or you can explain it by Mohr circle also. And according to the principal stress, if we draw the Mohr circle, we can find the principal stress, and also we can find the maximum shear stress also. Okay, so we will move to just another example, that is maybe you may find that it is the show you the state of stress at a point for the particular case that we familiar with. If we consider the state of stress for the case that we apply the uniaxial load for bar like this, we will find that is the state of stress at this point. It just has only the normal stress, that is sigma x equal to p over a, and then sigma y and tau xy become 0. So according to this, we can draw the Mohr circle like this, and this is define the state of stress. That is, we can write the state of stress at a point by picture like this. This is sigma x only. Okay, and sigma y is become 0, and also sigma tau xy is equal to 0 also. Okay, so when if we consider another plane, okay, for this case we consider the stress along this plane, okay, we see sigma x. Okay, but if we consider the stress along this plane instead, okay, we will not we will find the components of the normal stress, that is for this case it is the principal stress. Okay, so according to this, if we consider this plane, so it means that we have two components, that is normal stress and also shear stress. Okay, and also shear stress. So according to this, if we rotate to 90 degree in Mohr circle, that is mean that it may be rotate with 45 degree, okay, of the plane, of the real plane. So we found that sigma x, okay, if we rotate to this point, that is 90 degree in Mohr circle and 45 degree, we found that the normal stress and shear stress are equivalent, and is equal to P over 2A. Okay, that is the point that the maximum shear stress is occur on that point. Okay, that is for, it can explain that why when you giving a
ครั
talk
บ
to
อยู่ไหนแล้วครับผมอ๋อพี่ฝากไว้บนโต๊ะสแตนเลสได้ไหมเดี๋ยวผมลงไปเอาครับใช่ครับวางไว้ได้เลยครับเดี๋ยวผม